So if you could please join me in welcoming to the stage our 10th competitor, Omar Yadak. All right. Omar is joining us from the Department of Civil Engineering and Environmental Science and is going to be talking with us about his research entitled Accelerated Bridge Construction, Evaluation of Column Footing Connections for a New Innovative Column Design. Thank you.
Have you ever found yourself wondering about the state of those bridges that you cross over every day? Well, did you know that 50% of the nicest bridges have surpassed their design life cycle? Or did you know in Oklahoma, 21,000 bridges are classified to be structurally deficient and needed to be replaced? Deficiency leads to catastrophes like bridge breaking or column buckling. And that could be even worse with having the wild dance of the Oklahoma weather. So the May Avenue Bridge here is an example of a bridge collapse happened in Oklahoma in 2016. But the good news, the Oklahoma Department of Transportation is currently embarking on a new journey of bridge rehabilitation with $150 million. But you know, construction takes time, and sometimes you might find yourself stuck in traffic, frustrated with those detours and road closures. So this is why my research comes in place. I'm contributing to what's so-called the Accelerated Bridge Construction, ABC method, where it's basically constructing large portions of the bridge off-site and on-site and then connect them quickly on-site. It's like putting Lego pieces all together. But as we aim for ABC, new designs of structural elements should be developed. So in my research, I focus on a new column design. This column has an inner hollow steel tube, an outer hollow plastic tube, and concrete is only filled in the gap between these two tubes. Since it's a new column design, I evaluated several innovative connections on how to connect that column with other structural elements like beams and foundations. Studying this connection is important because as engineers, we want to make sure that the loads coming from cars, trucks, are transferred properly and safely from the beams to the column to the foundations. I made 9 specimens representing that column foundation connections to evaluate 5 different parameters that could potentially affect the strength of that connection. I showed the significance and the importance of that connection based on the embedment depth of the column into the footing and also the effect of the steel tube diameter, the diameter of the steel tube thickness ratio to performance of that connection. So, as an engineer, I'm trying to aim for a future where our bridges aren't just structures, but symbols of resilience. So this design aligns well with the concept of ABC as it's more durable and using 65% less materials, more sustainable, and easily constructed on-site. And with that, I would like to say thank you.